Okay. Um, your tests actually got graded, but they're in the press box. I forgot them. So I got here to school and I was going to pull them out so I could put them in the grade book, and I hope that's where they are. I'm assuming that's where they are because that's where they got graded. If they're not there, then you all get hundreds. Yeah. Don't have to do anything. Okay. Here we go. 2-1. 2-1. Kind of keep up with the calendar, make sure you know what's going on, what we're doing in class. So we'll do 2-1 today. Unit 2 is really a lot about exponentials, right? So Unit 1 was a lot of polynomials, right? We talked about max, mins, all that stuff, asymptotes, right? Now we're going to start dealing with exponentials. So this first page or this first section, we're talking about sequences. So in pre-cal, we deal with sequences. We don't deal with series. We used to deal with sequences and series. But this is a topic that's pretty big when you get to Cal 2. So anyway, this is pretty much an introduction to it. Not much more than just exactly that, just an introduction. And we're only going to talk about 2 different types of sequences, and it's arithmetic and geometric. Okay, so those are the 2 sequences we're going to be dealing with. Okay, so here we go with that. A sequence is a function, from the whole numbers to the real numbers. This is not I don't know why. I wouldn't write anything down there, but it is what it is. A sequence, it's a pattern. It's a pattern. So if it's 0 and then 2 and then 4 and 6 and 8, it's a pattern, okay? We input whole numbers. That's the only thing we input. We do not input fractions, decimals. We only input whole numbers. And so what I mean by whole numbers is whole numbers could be a 0, HWHO. That's how you know that there's a whole number starts at 0, 1, 2. We don't have any negatives. So 0, 1, 2, 3, up to whatever number we want to go to, okay? So this means we're only able to plug in whole numbers, 0, 1, 2, 3, ... into a sequence. But we can get any number out. We can get anything out. You can get a fraction, you can get decimals, you can get radicals, you can get anything out. We're only inputting whole numbers. As a result, when we graph a sequence, you will only have points, because you'll have a point at 0, whatever it is. You'll have a point at 1, whatever it is. And you'll have a point at 2, whatever it is. But there's nothing in between it. So sequences don't connect. They're just actual points. They're discrete values. It's not continuous. Okay, with all that, just kind of soak all this stuff up. I mean, I don't know how much of this will be asked to you, but I think it's one of those things, the more you know, the better off you are. As a result, when we graph a sequence, we only have points. We cannot connect them. I just said that. Okay. So here we go. This is example number 1. We just jump right into it. So consider a sequence defined by a sub n. That's how they'll define these. They'll define them as a sub n. They might use g sub n, okay? There's a reason why they use a, and there's a reason why they'll use g, but a sub n is equal to 4n minus 3. So this is somewhat linear, but it's not linear because we don't connect it. But it's just, we have a slope and you have a y-intercept. So at least you can recognize that that's a slope and a y-intercept. Good. But they want me to find a sub 1, and then they want me to find a sub 7. Well, if I just go from a sub 1 to this over here, this is a sub n. If this is a sub n and I want a sub 1, and this is a sub n is 4n, then I want 4 times 1 minus 3. And basically all you're doing is plugging and chugging. Okay, so plug the 1 in. 4 times 1 is 4. Minus 3, 1. Easy enough? Not bad? This shouldn't be very taxing on your brains, I hope. And then they want me to do a sub 7. Bless. So 2 times. So a sub 7. Well, that'll be 4 7s minus 3. And so a sub 7 will be what? 28 minus 3, 25. And if you can do that, that very well could be a question on the next exam. Good enough? They'll give you some I don't want to say function, some statement. I guess I should say some statement. They'll tell you what it is, and then they'll say what is a sub whatever. Okay, so in the grand scheme of things, this is kind of like the first term, and this is like the 7th term. But neither here nor there. In this course, we're going to study 2 types of sequences, arithmetic and geometric. I said that already. So here we're going to spend the first whatever time we need to go over the arithmetic sequences, okay? Successive terms have a common difference. That's how you know it's arithmetic. If it has a common difference between every term. So if it goes from 1 to 3 and then to 5 and then to 7, it has a common difference of 2. Okay, so everybody, you have to have a common difference in order for it to be arithmetic. If it doesn't have a common difference, it's not arithmetic. Just that simple. Has to be a common difference. Common difference. Or a constant rate of change, if you want to call it that. So now we're kind of, instead of doing something that seems really common sense, we got to pull this stuff from chapter or unit 1. A common rate of change, because it's going to be somewhat, I say linear, but again, it's not going to be a linear because we're not connecting the points. But the dots will go in a linear fashion. Yes, ma'am.
I guess you shouldn't ask this, but will we be using like the regression functions?
No, not for sequences and series. We'll use regressions, but for exponentials. Okay, so there's 2 formulas you can use. 2 you can use. You have to memorize them. They're not anywhere for it to be known. So you just have to memorize them. My suggestion is write it down every time. I actually don't use this one because that only works for when you have a sub 0. That only works when it is. This one works every time. Every time. So I recommend just having that formula. That way you don't have to remember 2. That one, like this one, covers everything. This one only covers a, bless you, a 2 times, 3 times. Breathe. Good. This one only covers if you know a sub 0. And very seldom will you know a sub 0. So I don't use this formula. I just use this one. So a sub n, I mean, you guys can see it, but I just write it down until it comes to my head, and now I know it. A sub k, then plus d n minus 1. It's not a horrendous formula. It's just something that won't come natural to you until we just do it so many times. Okay? Say again? Oh, it's k. That's what I said. See, I can make out a k real easy. Good? There's a reason why I did it that way. All right, so where again, a sub 0 I'm not using because this one doesn't have an a sub 0, fair enough. But that would be like I think they call it the initial term. But like I said, I don't use a sub 0 because I don't use that formula. I just use the second formula, okay? D is that common difference. D is that common difference. I don't know. A sub k is that value. That's probably not what they said, but I think knowing how to do this is better than this definition right here. D is that common difference, and then a sub k is that value. Arithmetic sequences behave like linear functions. They behave like linear functions, except they're not continuous, right? They're those discrete values that we talked about. But they look like a line if you did connect them, either positive or negative. Increasing arithmetic series, increase equally each step, slope always stays the same. Yeah, whatever. Finally, let's go. Let's get into something that. Three n plus 1. I guess they just want me to draw a picture of this. 0 is 1. 0 plus 1. 1, 3 plus 1, 4. 2, 6, 7. Okay? What? Huh? It's like, huh? I mess up? No. Shut up. Grow up. 10. Good enough? Y'all okay? The mistake that some students will do is they'll connect those stupid things. Don't do it. Don't do it. Don't do it. Don't do it. Okay? Those are discrete values because we don't have a value of 0.5. We don't have a value of 1. There's no values because it can only input those whole numbers. Okay? So it can only do that. All right. Beautiful. Here we go. Example number 2. I don't know what they want over there. Oh, they might want a table. Let's do that. Let's do that. Let's do n and a sub n. And then we'll just make up some numbers. So we'll just do 0 and 3 and 1 and 4 and 2 and 7 and 3 and 10. You can see again there's a common. Where'd I mess up? Oh, this is supposed to be a 1. Gosh dang it. See, I knew I messed up because there's supposed to be a common difference. 3, 3, 3. If there's not a common difference, it's not arithmetic. So we did one of two things. We messed up or it's not arithmetic. Okay, good, beautiful, beautiful, beautiful. For each of the following, determine if the sequence could be arithmetic. If yes, identify the common difference. So, I don't know. Plug in 0, plug in 1, plug in 2, and see if they're common differences. 0, negative 3, 0 squared. 1, 1 squared 1, 1 minus 3 is negative 2. 2 better be negative 1. 2 squared is 4. 4 minus 3 is positive 1. Nope. I can stop right now. If you're not too sure, you can go another one, right? 3 squared is 9. 9 minus 3 is 6. No. There's not a common difference between whole numbers. Bless you. Next one. I can tell you that it is. Because what is the slope of that one? No. Negative 2. So my guess is D is negative 2. But we can make ourselves feel better. 0, 6, 1, 4, 2, 2. It's looking good. If you feel better, put a 3 in there. 0, 2, negative 2, because you're going down 2. Negative 2, negative 2. D equals negative 2. Whew! Man! Easiest test you guys are going to take all year. Told you, stuff's easy. One question on your test. This one, I don't have to make a table because I already have a table. So I'm just seeing if it goes down constantly. That's going down 5. Went up 5, sorry. Then 2, 1, 0, 1, 2, 3. Went up 5. Went up 5. D equals 5. 1 to negative 2. There's no way because it's going positive, negative, positive, negative. There's no way. That's nothing. Y'all okay with arithmetic sequences? Or beautiful? I don't think we're done. No, we're not. This is going to be a little bit harder here. All right, so let A sub n be an arithmetic sequence. A sub 3 equals 8. A sub 3 equals 8. D equals negative 3. Well, as soon as I say it says find an expression for A sub n, I'm going to go to that A sub n equals A sub k plus D n minus k. Okay, let's write it down and just you got to memorize it. So the night before test, make sure you just go over that until you can't go over it anymore, right? A sub n is what it's staying a constant. A sub k, well, now I'm going to go to what they gave me. They gave me A sub 3. So I'm going to do A sub 3 plus, well, I probably shouldn't have said plus. I probably should have said minus because it's D. Okay, so I'll just do a plus and negative. N is always the variable. We're not plugging in anything for n because I'm looking for A sub n. So if that's an n, this is going to be an n. I'm just kind of plugging and chugging exactly what the variables say. So this is A sub n. This n and this n are the same thing. This k and this k are the same thing. And the D, of course, they gave me. So I'm just plugging and chugging stuff in. N minus, and the k was the 3. Okay, yes. D is negative 3, A sub 3. You're okay. I can see they should have chose a different number than 3. Okay, so the k came from this 3 because it's A sub k. And what am I going to replace A sub 3 with? 8. Got to replace it with the 8. So I've got A sub n. I'm going to put the 8 right here, minus 3n. I'm going to go ahead and say plus 9. I hope I didn't do too much math to overwhelm your brains. Let's combine it a little bit better, and we'll say A sub n is equal to, and they don't care if you want to do, they don't care on these guys. They don't care if you want to do 17 minus 3n or minus 3n plus 17. Doesn't matter. It says the same thing. They're not nitpicky about that. So if you want to do 17 minus 3n, or if you want to do negative 3n plus 17, just make sure the negative goes with the 3 and the positive goes with the 17. And then make sure the 3 goes with the n. Yes, no, maybe? So get comfortable with that formula. We'll do it again. Because this particular one here, they didn't give me D. They told me that A sub 2 is 7. A sub 2 is 7. Whoops. And A sub 6, I just changed my A's up, is 9. They didn't tell me what D was. But I don't think it's a overwhelming brain buster to figure out what the heck D is. Because in between 2 and 6, that's how many integers or how many whole numbers? 4. And in between 7 and 9, it's going to be a 2. And so to get 4 digits to 2, I think it's going to be, D is going to be 1/2. And if you can't figure that out, you can put 2 over 4. Put the difference here over the difference here. And so the difference there is 2 over the 4. I need 4 numbers to get 2. However you got to do it. It's going to be 1/2. So that equals D. So now that I have D, I'm going to go back and I'm going to say A sub n equals A sub k plus D n minus k. And again, my suggestion is to keep writing it down. I have to look at it every year. I haven't seen it for 2 years, and I had to do it this morning, and I had to write it down 4 or 5 times so I can try to remember it. A sub n is what I'm looking for. And guys, it doesn't matter if you use this one or this one. You can use either one. Use either one, whichever one you want to use. If half of you use A sub 2 and the other half of you use A sub 6, you're going to end up with the same number at the end. So I use A sub 2 because that's a smaller number. So I'm going to do A sub 2 plus, we said D was 1/2. N is still n. And if I use A sub 2, then K has to be 2. If you did A sub 6, then K would have to be 6. And A sub 2 we decided was 7. And so if you want to put the 7 in there like that, that's okay. And so we got A sub n, 7 plus 1/2 n minus 1. 7 minus 1 is 6. 6 plus 1/2 n. And if you use the other one, you would have got the same thing. Is everybody okay with how I got the 1/2 for the D? Okay. Sometimes it's not quite that easy, but again, if you just put that over the other one, that it has to be that common difference. So you'll have some practice for those on your homework tonight. Everybody okay with arithmetic? Oh, there's one more, I'm sorry. You can tell it's arithmetic because it's going down in constant numbers. Go ahead. Plug in n for, oh, that's right, because I had one more part. That's right, I'm sorry. That was the easy part, right? Because now it wants me to find A sub 24. Sorry, thanks. So once you find A sub n, right, A sub n is that, they want me to find A sub 24. So A sub 24 is 24 times 1/2, which is 12. 12 plus 6 is 18. And I don't know how much work you want to show on that. Homework, you probably don't want to show a whole lot of anything. If it's a test, you probably want to show something just in case you don't know how to add or subtract, and we can at least backtrack and try to figure out where you messed up. You're supposed to plug and chug on this other one too, I think. Oh, they wanted A sub 12 on this one. Okay. All right. Whoops, I didn't do this one. Okay, here we go. So back to this one. We have arithmetic because it's going down in constant terms. It went from 8 to 6, 6 to 4, 4 to 2, 2 to 1, or I'm sorry, 2 to 0. So we're going down 2 per. So D is going to be a -2. D is -2. And I'm going to write my little statement. A sub n is equal to A sub k plus D n minus k. What's up? Can I sign this for you?
For the library, but.
Oh, yeah, sure.
Thank you.
Cool. Wow. Cool. I get to sign this. If anybody ever wants to be student of the month, just let me know and I'll nominate you. But you better be good. You're so welcome. Good to see you. Okay. So now we're plugging and chugging in this one. Again, you can use, there's what, 1, 2, 3, 4, 5 points. Use any one of the points. I would use A sub 0. I would use A sub 0. So a sub n is equal to a sub 0. What did we say? Down 2, right? So minus 2n minus 0. Y'all see why I would do a sub 0? Because then it's just n. That's that first formula. That first formula just basically takes the k out of it. A sub 0 was 8 minus 2n, and you're done. They want me to find a sub 17, and so I would do 17 times negative 2, negative 34, negative 34 and 8 more, something like negative 20, I don't know. Good? Yes, you can get negatives. Yes, you can get decimals. Yes, you can get all kinds of things on the output. Inputs, you can only have whole numbers. Okay, arithmetic. Y'all good? Geometric. Work very, very similar, except geometric do not go in a linear fashion. They will go in an exponential. So that's kind of why we're doing this. We're kind of introducing you to exponentials here. So one of the things we got to be able to recognize the difference is the difference between a linear and a difference between an exponential, okay? So in an exponential, they don't have a common difference, they have a common ratio. They have a common ratio, not a common difference. A common ratio. So you're going to be given some sequence and they're going to ask you, is it arithmetic, geometric, or neither? If it has a common difference, it's arithmetic. If it has a common ratio, it's geometric. And if it doesn't have either one, then it's neither. So it's not that difficult. Here's the formula. Again, I don't use the top one. I just use the bottom one. I just use the bottom one, okay? And that's for the same reason. You got to have G sub 0 for the top one. And if you don't have G sub 0, then you got to use the bottom one. And if you have G sub 0, the bottom one works. So I would just use the bottom one. And it looks pretty similar, truthfully, because now they don't do A sub n, they do G sub n, because these are geometric. G sub n equals, and they'll do G sub k. This starts off the same way, A sub n, A sub k. And then they put plus D because there's a common difference and the difference is added. Well, they're not going to do plus D, they're going to do times R. Okay, so instead of plus D, it's times R, because that's what exponentials do, it's a multiplication. And then they're going to put the n minus the k as an exponential, not multiplied. So it's not too bad difference. So G sub 0 is the initial. Again, I don't care about that. R is that common ratio. And G, I don't know what I put last time. Value? I don't know. I don't know if that's going to help you any or not. Geometric behave like exponentials, except they're not continuous. Increasing geometric increases by a larger amount each step. In other words, they have a percent of increase or a percent of decrease, however you want to say it. Here's my example. We'll go over here and do points first if you want to. 0. So this is G sub n. Or let me rephrase that. This is n, and this is G sub n. 0. Anything to the 0 power is 1. 1 times 8 is 8. 1. 1/2 to the 1 is 1/2. 1/2 times 8 is 4. 2. 1/2 squared is 1/4. 1/4 times 8 is 2. 3. 1/2 cubed is 1/8. 1/8 times 8 is 1. You can see how basically we're getting divided by 2 or multiplied by 1/2, however you want to say it. Multiplied by 1/2 or divided by 2 or either one. And so it's not a common because this is 4, this is 2. This goes back to, gosh, was that the very first one we did where we figured out the differences between them? And the second difference? Okay, here we go. For each of the following, determine if it could be geometric. If it is, identify R. So 0 into the 0 is 0. 0 times 3 is 0. 1. 1 squared is 1. 1 times 3 is 3. Yuck. It's not looking good at all. 2. 2 squared is 4. 4 times 3 is 12. Well, this common, that's 4. That's not 4. So it's nothing. That's 3. If it's going, actually, that's not even 3. That's like 0 times anything is 0. Like, this is starting off bad because of the 0, 0. Nothing. Zero. That kind of looks like the geometric formula, right? So it probably is. 2 to the, let's see, 0 minus 1 is negative 1. 2 to the negative 1 is 1/2. It flips it. 1/2 times 4 is 2. 1. 1 minus 1 is 0. 2 to the 0 is 1. 1 times 4 is 4. 2. 2 minus 1 is 1. 2 to the 1 is 2. 2 times 4 is 8. This is looking good. Because you got to multiply it by 2 and multiply it by 2 and multiply it by 2, so it's looking good. 8 over 4 is the same thing as 4 over 2. D, whoop, I didn't want to say D, I want to say R equals 2. Common ratio is 2. 1 to 3 is 2. 3 to 2 is 1. 2 to 6 is 4. This is 2. This is absolutely nothing. Nothing, neither, nope. 16 to negative 8. That's negative 1/2. Negative 8 to 4 is negative 1/2. 4 to negative 2 is negative 1/2. R equals negative 1/2. You can put negative 0.5. Basically, it's whatever that common ratio is, whatever you have to do. I just put this over this. I put the right one over the left one. Right over left, right over left, right over left, right over left, and all of those are negative 1/2. Almost done. They're telling me we have a geometric sequence with G sub 1 is 12 and R is equal to 2. Find an equation. G sub n equals G sub k. R n minus k. Plug and chug. G sub n. G sub k, which is G sub 1. R is 2. N minus k. K is 1. And G sub 1 is 12. And the first knucklehead that multiplies a 12 and a 2. Because you're no good to society. Because you don't know anything about mathematics. You can't multiply those together because everybody knows what. You have to do parentheses first, and then you have to do exponents. So I got to do this exponent before I can multiply. So you cannot multiply those and make it 24. Although one of you knuckleheads is going to do it. I just hope it's not one of you guys. Because we're going to put our tests together with other tests, and somebody's going to say, oh, there's one. It better not be one of my guys. Because I'm just going to. I'll do this on the test. Put a smiley face. I'll just do that and then put minus like 20. Because you don't know anything about mathematics. Yep. No, but you'll get plus 4 points. Because you'll get it right. We're supposed to find G sub 4. We're supposed to find G sub 4, so plug in 4. 4 minus 3, I'm sorry, 4 minus 1 is 3. 2 cubed is 8. 8 times 12 is 96. Several are shown here. Find the value. I would use G sub 0. G sub n is equal to G sub k r n minus 1. G sub n is equal to G sub 0 r 8 to 4, 4 to 2, that's 1/2. Oh, n is 0. No, no, we're good. What's G sub 0? G sub 0 is 8. Y'all good? Y'all happy? Y'all ready? What else you want? You got 2 assignments tonight. What are you left?
I don't know.
Stop. Now you're on YouTube. Ha ha ha.